Okay, I think we can kick off. So hi everyone and welcome to today's session. Really excited to have you all join us. So today is actually part of the Global Azure Days, which is a global, worldwide, as the name suggests, series of events all around different applications of Azure with lots of different speakers from external communities primarily, talking about kind of different ways to use Azure. So it's pretty exciting. My name is James Woolard. I run the Reactor program across Europe and the Middle East. And I'm really kind of happy to be joined today by Ekaterina Marinova. So she is a Microsoft MVP, and she's also an AI and data innovation strategy specialist. So she's going to be taking us through today's session. Before we get into that, I just need to run through our code of conduct. Basically, you have all got the opportunity to post questions in the chat, and we encourage you to do so throughout. We do remind you this is a global event. There are lots of people involved from lots of different backgrounds. So just to be really kind of considerate, kind, and respecting of other people's views as we go through the session. So I think that's pretty much it. We will get straight into the content. So we're going to be looking into AI in a bit more detail, so how we can bring artificial intelligence, machine learning into your organization. So with that, I will hand over to you, Ekaterina.
Thank you so much, James. Thank you very much for the introduction. So today, let me just share my screen. Okay. Sharing. I hope that you can see it now. So today I'm here as I'm an MVP for AI. And what does MVP mean? So MVP is most valuable professional. I'm part of the community, Microsoft community across the globe, and right now I'm based in Bulgaria. So I'm actually leading some community events, presentations that are related to AI, really participating actively in the Microsoft workspace with AI workloads, and also collaborating with other community members on different topics that they are experts in. I've shared this slide here, not just for the speaker info and to present myself or the post and pre-COVID picture and video right now, but just to share that everything that I'm going to talk today, yes, it's also Microsoft content. It's related to Microsoft and Azure technologies. But I'm speaking, and what I've developed here and what I've created here as slides is a product of my experience in 3 dimensions. So I started my career at Microsoft a few years ago when I was working as a data and AI solutions professional. So really more on the selling side, more on the consultancy side. And then I decided to switch and go to an integrator and really see how are we actually developing those technologies, how are we implementing those technologies to our customers and to the clients. Today, I'm here as data and innovation strategist also at Raiffeisen Bank, where I'm already at the customer side, really accepting those solutions and seeing those solutions in actions. And I'm mentioning this because these are the 3 perspectives that I believe are necessary in order to have the vision of a solution. So really the vendor side, so the technology side, the implementation side, and the customer side. So what does the customer want? How are you going to do it? And what is it offered on the market? So with this, I would like to start today with a bit of an introduction, because right now, all of us, we are located in the era of data, right? So we are walking on the street, and then we're seeing, and we are being tracked by different sensors, and the weather has been tracked by different sensors, the traffic, what our movements are, and so on. So there are cameras around the different stores. There is all this data proliferation that is gathered by so many different sources around us. So we can easily say and bravely say that we're in the era of data. But often we're talking about data, big data, so everything's about big data. But how do we actually define big data, right? And you've all heard of the 3Vs. So we're talking about volume, velocity, and variety of the data. So these are the 3Vs that are describing big data. So it's big, of course, as quantity. It's various in terms of different sources of information, and then the speed of processing of this big data. Here, I would like to point out two very important components, though, that are very important for today's session and today's presentation, and these are the trustworthiness and the value of the data that we are considering. So two more factors that are describing big data as such, as we are working with it. And at the first place, of course, to what extent are these sources that we're looking at trustworthy so that we can include them in our decision-making process, in our analysis, in our machine learning, in the artificial intelligence model that we're designing. And then to what extent is the data that we're collecting or this big data that we're working with valuable for us? So these are all important components that we should take care of when we are considering working with big data, when we are considering talking about big data. But then getting one step ahead, we're talking about these data points and these data sources around us, but we could easily say that analyzing them, extracting the knowledge of them, brings us to the era of intelligence, right? And if we're just looking at them as data sources and data points, that's good. These are facts. But what are we exactly trying to do with them? So measuring the weather is good, but measuring it with what purpose? With the purpose of air pollution, with the purpose of establishing different factors around us that are going to define it. So with this era of intelligence, we're also heading to digitalization. So we are getting into more data sources, more data points, more intelligence. So a better opportunity for us to make data-driven decision-making, to utilize more technology to gather the data, being agile, adaptive to what's happening around us. So if we're talking about automations already, we need to adapt to these automations and be able to still extract the same knowledge. And thus, we're welcomed into the era of artificial intelligence. And now artificial intelligence and AI, this is a term that's so widely used and then so narrowly defined. So very few people can actually define AI in the same way. So probably if we're three people here now, the three of us would define AI differently. But at the end of the day, we're asking so many questions about AI. So who understands it? What exactly is AI? For example, if you have iRobot around the house, if you have your vacuum cleaner, is this AI? If I call now Alexa or Google, are they AI? Are we just mentioning AI because it's fancy? Are we saying that we're doing AI, but then we just do what ifs and automation? Who invented it? Where is it? And then we can go with all those questions. So is AI around me? Am I AI? We can get to the very big question. So where is the ethical part behind the AI? So is this ethics? And we can get to the topic of AI conquering the world, right? Which is very, very extreme in my opinion. But these are different questions that we're asking. But if we have to simplify and really try to first, before we ask this question, really understand what is artificial intelligence, we can decompose it into that. Artificial intelligence, this is the human intelligence and the human actions invested in enough speed to processing, in enough machine memory, and in enough computing power so they could get the results that we want. If you think about it, if you think of an algorithm or of the actions, for example, of a robot, first of all, we design those actions. First of all, we invest this human intelligence. We invest what we know as people and what we produced as our intelligence has produced. And then we use computers, we use the cloud in order to scale it, in order to develop it, in order to allow this machine memory and this computing power to actually train models, think of the different scenarios and integrate it within this robot. So starting with that, defining AI and defining the artificial element. So really, it's much more easier to define artificial than intelligence. But if we combine those two, this is what artificial intelligence actually looks like. Very important is that artificial intelligence is composed of several things, several technologies. On the first part, we have machine learning, and we're often taking those two apart, and I also took this apart in the title of this session. But machine learning is actually part of artificial intelligence, so it's there, it's within the bubble. Machine learning is really using predictive analytics, using statistical modeling of training historical data and producing outputs. And this is artificial intelligence, right? Because we have the human intelligence behind. So what do we want to do? What is the data that is collected there? What do we want to predict? Really select what are the variables to predict. And then we invest this into a machine. Then we're talking about several elements like natural language processing, so translating, extracting information from a set of textual data. We're going through speech and really being able to, as I talk now, Word can write down my session, right? And then I can have it into text. And also reading out loud, the machine can read out the text that I've listed there. And then we're talking about robotics, vision, and expert systems. These are all parts of artificial intelligence. And artificial intelligence is such a broad concept, but also combines those very, very specific dimensions. And with this introduction, actually, I'd like to start today's session, where we're going to be finding really what is the strategic approach towards AI. Now, putting ML there, so machine learning and AI, and you as an individual, you as a team, you as an organization. And very important before we begin is that every strategic approach and every AI strategy is really defined by the maturity. So your maturity, the maturity of the organization, the environment around us, and the technology bouquet that you're working with or that you're exploring or that you need to learn in order to apply this strategy. Because technology can come after, but technology can also push the strategy. So with this, I would like to start with the session of bringing artificial intelligence to you. So we're going to be talking today about the organization's path towards AI and ML, the Azure technologies that you can utilize in order to do so, in order to be powerful, in order to realize this strategy. And then I'm going to do a demonstration of few technologies that I believe are very critical and very interesting and innovative for you if you want to start building it. Before I begin, I would like to also say that I'm not the deep technical person that you might expect. I'm not a data engineer. I've been a data scientist and data analyst. Today, I would like to present this from this perspective. But I'll be willing to answer all of your questions, or if there are some data engineering questions, just take them aside and answer them later. And with regards to this comment, I would like to start really now first with the data Maslow pyramid. So the data Maslow pyramid is really, this is the concept that gets to the engineers, that gets to the business, gets to the data scientist and the data analyst. So in order to get to the AI and to the machine learning components, in order to be discussing them at all, we first start with the very basics. So tracking data, tracking the behavior, events, data points that we were mentioning in the very beginning. So first, be really aware of where your data is. What is the data that you would like to collect? So I'll be thinking about the different applications. I'll be thinking about the different systems. If I have IoT devices, I'll be considering IoT devices, right? So I'll be assessing the environment or I'll be researching a different environment. This is the business and the data understanding phase of the data mining process. So I'll be assessing what's around me in terms of data sources and data points before I can proceed further. So first of all, I know where my sources are. Then I can climb up to collect those data points, and really store them in the appropriate technology or in the appropriate database that I've selected. Then we are going into the ingestion phase, so really combining the different data sources and utilizing them in a table or in another environment where we would like to continue with the data processing and the data transformation that we need to do in order to get to this very upper part of the pyramid, which is the dashboard and the analysis. So the extraction, the insights of this data. So being able to see the 10 different sensors, for example, around me that are measuring the weather, being able to visualize them and to be able to start getting insights and go to the data-driven decision-making state, where, for example, I'll be saying, okay, I can monitor, for example, that one of the stations is broken, or I can monitor that one of the station is not working properly and is giving a different temperatures that are different that they should be in this period of the year. So we've tracked the data, we've collected, stored, ingested, and processed it. We've already visualized it and started gathering some insights. So here we're getting to the part of the machine learning element. So I have my data, I have my analysis. What do I want to do? Do I want to predict the weather forecast? Do I want to do time series forecasting for a shorter period of time? So I would like to see how is the pollution going every hour from now, for example, for the next 3 days. Or what do I want to do that is going to give me this advanced layer and this advanced approach on the insights part. And then in the end of the day, we're going to get to the artificial intelligence part and really think of what could be the necessary element or another element that I can top up with. For example, if I have the weather station now and I've analyzed it and started predicting it, I can see that there is some room for more data or there is room for further analysis. And I can be thinking, okay, I see that this region is polluted. Can I utilize cameras, for example, to see if the traffic there is heavy? And if I see that, I'll be like, okay, I can integrate this and we can start from the very beginning. This is an iterative process. It is a pyramid of the needs, and it's a pyramid of what do we need in order to get somewhere. Of course, we need the data and all the technical part until we get to the AI element. But also, this pyramid can be positioned in different ways of the different steps interacting between each other. What I've done on the right part, and these are some part of the technologies that the Azure platform is offering. These are the respective solutions that are built for each and every part of this pyramid. And you can imagine that within some of the layers, for example, data ingestion or data processing and transformation, you can have sub-layers there, and we can utilize even more technologies. But here on a high level, we can see that for tracking behavior in events, we have the Azure Bot Framework, the IoT or the Event Hub. For the collection and data storage, we have Azure Blob Storage and the Data Lake, where we can store, of course, SQL and so on. For the data processing and transformation and the data ingestion, we can be utilizing Azure Data Factory. And for the dashboard and analysis, here we're talking about Power BI, but we can also talk about Synapse. For the machine learning and AI part, and today we're going to see that, we can talk about the Machine Learning Studio, the cognitive services. I'm going to all show it to you today. As we move to the right, we can see that there are several technology solutions or stacks that are combining some of the powers of those very decomposed one in the very beginning. So Azure Databricks, for example, collects the data, ingests it, and really we're going into the data processing part. It also includes in there, so in Azure Databricks, we can have ML, machine learning integrated, but also the Azure Databricks component connects to the machine learning. And on the very top, there is one of my favorite solutions that I'm going to show to you today as a former data scientist and because I was used to more of the open source parts. This is the data science virtual machine. So utilizing virtual machine that's already pre-configured with what you might need for completing those steps that you can see here in the pyramid. And very interesting solution is the Azure Stack that can actually cover the whole pyramid. And now if you can see the dotted part at the very end, it's in preview, but we are also expanding to, Microsoft is also expanding to integration with the IoT and the Event Hub. So really aiming at covering the whole stack. So this is interesting. I'm showing those solutions just to gather the perspective now that if you are thinking about some of the layers, if you are somewhere on the pyramid already and you want to continue with further with solutions, you have the different options to start from different layers. And this is the beauty of the cloud, and it's agile, and it's very, you can be agile with the cloud services, right? Now, if we're going to the Azure Stack, I'm not going to explain now the different technologies. I'm not getting into the deep technical dive here of the Azure Stack, the edge, the data center, and so on. This graph here is to present you with the situation as most of the companies are in this situation. You have your on-premise data, you have the cloud possibilities, you have the machine learning in the cloud. So you're thinking, okay, what is the security? Okay, cloud is secure, but then on the other side, I have my sensitive data that I don't want to move, or the data that I cannot move. So there are so many different scenarios. I have my manufacturing side. For example, I have my stores where I would like to also communicate and be able to operate and gather insights there. So this is why Azure Stack is there. So here again, covering the whole pyramid, and here showing it that Azure Stack is a set of Azure services that are working together in order to be as practical as possible for you and as close to the business as this could be, with the specifics of the of creating applications anywhere, using artificial intelligence and machine learning on premises, but not only in the cloud, but also on premises, and also integrating with the different event and IoT hub devices that you might be having. When we're talking about artificial intelligence and machine learning, it's very important, as we already discussed, what do we have as data infrastructure? So the collection of the data, the processing, the security of the data, persisting the data quality, the availability of the system and the downtime, and very important for the business, the time to data. I've pasted here two very general architectures for Databricks and for Data Factory. How are they working? So that you can see that it's a very short step and a very short process when we're including it. And the machine learning, just to hide this, I don't know if you, sorry for that. Just to see the machine learning component and the Power BI that are very close here to Azure Databricks. That's just connecting to the databases, and also for the data ingestions. How are we implementing the Azure Data Factory? I've shown these two architectures just to not to confuse you or get very technical, but to show you that with what you have existing as infrastructure, you can enrich it and you can top up with other technologies. The most important thing is that when you are thinking of your cloud solution, you have to be taking into consideration that the data infrastructure is extremely important when you are defining the machine learning or the AI strategy. We're not talking separately about machine learning algorithms when we have not figured out the databases that are laying down, that are really ensuring that your data is there, that they're ensuring further, and also the people working with that their quality is good, that the security of the data is good, and that you have all the data points collected. And also when you get to algorithms and BI and AI, we here have to really know that we have the right data, and we can enrich it further by going down to the data infrastructure. And once we have the right data infrastructure and we've processed it, transformed and everything, we have to make sure that we're making the right decisions, right? That we are able and we have the tools of getting into the part of really being able to do a data-driven decision making. So here, what you can see is the different perspective of the business intelligence, the BI, so really the dashboarding, the analysis phase. And we can see that there are three perspectives of making a data-driven decision. The first part is really the past. So this is what we call the reporting or the reactive reporting. This is very common. This is very common for companies also that are not that mature, but also for most of the companies that have not invested a lot of efforts in this area. So this is really the reporting of what happened and the reporting of, okay, we're connecting to a database, let's analyze what we have on our tables. Or we're connecting to a different web service or to a different web page, and we want to analyze what has happened there. This is the reactive reporting. It works if you want to see really what are the trends and decide on an approach for prediction or an approach of what to do. So what happened with a certain campaign? Can we do things differently? The second aspect is the present aspect. So what's happening right now? And here we're talking about streaming analytics. And solutions vary across the different perspectives. So what's happening right now? We have our KPIs. For example, let's take the sensors outside that are measuring the weather and the pollution. We want to track every second or every 2 seconds, I don't know, just to see how are the sensors performing. Or if we go into a manufacturing scenario, we have our machines and we really want to see live what is happening, how are they performing if something has broken, for example, if something is broken. This is very important because for us, this costs money, right? And then we're getting into the third part of business intelligence and making the right decision. And this is really the prediction part, the what if analysis, the part where we are talking about what will happen. So we have the past, we have the trends, we have what's happening now, but here we can draw the line and draw the dotted line ahead and see what are the predicted values. So what is the predicted behavior of what we are tracking? And see, for example, if maintenance is required in the manufacturing part, or if we are expecting higher sales or lower sales, and be able to really manipulate our actions based on that. And it's not manipulate, but decide on better actions based on what we see as prediction. We can be also thinking of what if analysis, so being able to really try different scenarios and select the best one for us. And if reporting is that common right now, and I bet that all of you have and is using reporting daily, what in Azure is possible right now and what is possible in Power BI and Azure is really to combine these and to have the reactive, to have the future as well layer of intelligence there and of BI. Because right now, what you can do is really integrate cognitive services. So you can integrate text analytics, translation, natural language processing. You can even integrate anomaly detection. And now with one button, you can integrate your machine learning models there on the data set that you have selected and visualized, and be able to use the same dashboard into the different spheres, into the different zones, and being able to make the right decision based on what you really want to do. So if you have textual data and you load your textual data in Power BI, you can connect to the API of Azure for text analytics and being able, for example, to extract key phrases or to extract the sentiment analysis of the text there. So imagine a scenario where you want to analyze your feedback on Facebook or your feedback in Twitter. You download this, or the customer feedback. For example, if you have a chatbot, or if you have those, I don't know how are they called in the websites, if you know them, like rate your experience, or please type down if you weren't happy with some of our services. You can download it, you can load it in Power BI, and then you can load the text analytics API. And this is something that you can do for about 30 to 40 minutes, depending if you have the right data infrastructure there, if you have the data, if you've cleaned the data, or if you just want to run it on this part. And I know that cleaning of the data is most of the time, like 70% of the time, and it's not that simple, but like this is the capabilities that we can now utilize even within the visualization tool. And now we're getting to the part of really, we've done the infrastructure, we've done the insights. Now, what we have can get us one step ahead and enable us to do more. The power of the cloud, the power of technologies, the power of mathematics is really showing us and giving us this extra answer, or this extra opportunity to answer a question that we were previously not able to. So what is the next thing that our customer will buy? This is a common question. This was the start of machine learning with a case in the US of really predicting a woman was pregnant before even her parents knew, or she didn't knew. And then where to invest to optimize your cost, where employees leaving companies, how are we actually hiring employees? But this is a bit controversial here if you get into the machine learning of HR, so I'm not getting into that topic. Analyze time series data and being able to predict the pollution of a city, being able to do a forecast of different, for example, traffics, define green routes, define the best road to get, for example, on Google Maps. Do campaign management. Very, very common is the fraud or anomalies. And the anomalies, this is a beautiful case when we're talking about anomalies. Really, we're setting the different boundaries within a certain behavior and being able to detect it, learn it, train it within a system. If it's for our network, for example, the CM analysis, or if it's for credit cards, debit cards, these separations are very common. And then the last component, the artificial intelligence one, I've separated it because here I'll be including the vision element, the text analytics element, and all the others that we've already mentioned. So now, Microsoft presents an AI platform, right? And it makes it easy for us to be able to do the one-stop shop and to be able to really start with AI. So look at the infrastructure, look at the tools, and look at the different services. We've covered the services part with the cognitive services where we have this vision, text analytics, and so on. We're talking about services like conversational AI and bot framework, and also the Azure machine learning part. Today, we're going to take a look at those. The AI infrastructure, we're talking about the collection of data in the data lake, in Cosmos DB SQL Server, and then really computing, ingesting, and so on, where is the AI compute part. The different AI tools that we have, and they're open for people that are actually fans of different frameworks, that are fans of open source, of notebooks, of different technologies, so that you can be as powerful as you want and invest as much as possible of your human intelligence into the power of the cloud that has enough security, machine memory as you like, speed to process, and so on. So be really able to create your AI, right? Not AI, but your AI. So your intelligence in the same compute space or the same machine space. I'll just call it machine space. When we get to the cognitive services API, sorry for the typo, I was obviously excited with cognitive services. But when we're talking about the cognitive services API, this means that we can directly take a service that's related to language, speech, machine learning, vision, search, and knowledge, and insert it into an action that we want to do. So insert it into application, insert it into our phones. There was a case a few years ago, people were tracking pizza quality, for example, with that. Or on the production line, producing bulbs. You can use, for example, the vision API and the image recognition to check if a bulb is broken or it's okay. We're talking about the understanding text better. We're talking about different feedback analysis. We're talking about sentiment scoring, anomaly detection, and so on. We don't have that much time to go through those. I'm going to show you the repository today where you can click around and think of the scenarios here. And now when you have, and when you're building your strategy, when you're defining the infrastructure elements, then the BI part, and then you're thinking about ML and AI, you might be thinking and really decomposing the AI part into those different cognitive services and different data sources that you would like to collect, and then go into the machine learning part and really be thinking of what do I want to do. And I'm saying this because the data science process, so the machine learning process, conducts of 6 phases. And another way to call it is crisp DM modeling. It's very old, but it's really in the core of the data mining and the data science. And the crisp DM, or those 6 steps described here, the first part really contains the what is it, what are we doing, the business understanding phase. And nobody can actually do machine learning better than you as part of your organization, because at the first part of the business understanding part, you can hire researchers that are going to read, for example, 50 documents, 60 documents, in order to define the critical variables or factors for you in order to do your algorithm. But you can also utilize your business knowledge, invest it there, and be able to do it together with the technical guys and say, this is important for us. These are the important variables and components and data sources for us. We know it from our business experience. We know it because this is our business. The second part is picking the data. So really, if I'm talking that I need an external source for tracking the pollution and the weather, I need the camera outside and track the traffic. Now I have to be thinking, okay, do I have this data source and how can I get it, right? And this is the first iteration between step 1 and step 2. Then we are getting into step 3, which is the hard part. Nobody likes it. Nobody wants to do it. I've actually met one person that loved it, which was interesting. But this is the data cleansing. So garbage in, garbage out. This is the nice way to say it. Here we're cleaning the data that we've collected and preparing for the modeling part, which is the very deep data science work. So picking the right algorithm and being able to feed it with the right data and get the last accuracy of the model and the different variables that are important. And then we're going into the evaluation phase, and then we can start from the very beginning and the deployment phase. Today I'm going to show you the Machine Learning Studio. I see that we're a bit ahead in time. But what I want to actually show you there is that right now we're already talking about ML capabilities that are beyond, first beyond writing the code, but they're also starting from the drag and drop. We're now talking also about automatic machine learning and automatic selection of algorithms, and then automatic production of the best result. So you can go and you can use the technology to clean your data very fast. You can see here on the right, clean missing data, normalizing data. But you can also do modeling with AutoML and just click your data set, then click compute power, so human intelligence, machine intelligence, and then the machine is going to produce, it's going to conduct multiple models and then give you the best performing one, which is fairly very, very good. And the cherry here, the cherry of the cake, is that we're having those different technologies, but you are also able to directly install a data science virtual machine where you have all the capabilities and all the technologies that you might need or want in order to go through those steps that we've defined. So there is Power BI, machine learning, Apache Spark. So you have RStudio. I'm an R person, so this was pretty comfortable for me. Python and so on. The data science virtual machine is very easy to start and very very friendly for people that have not started this process, because they have all the technologies in one place and they can kick it off. They can really start with that. Different scenarios. As you can see, different solutions. The Azure platform is very rich when we are talking about the different needs that you might want. So the AI development, the cloud on edge, or the end-to-end IoT analytics platform, for example, at the very end, where you're visualizing your IoT data at scale. So these are all the different solutions that you might need in order to get into the different scenarios. So much information online. We can really just scratch a bit now today with the presentation, but I would like to open your minds when you're getting through the process, following the pyramid, and being able to select your technology and being able to select your solution. Very important is to start with strategy. So when you are implementing and when you are defining your road to AI, to ML, start with the strategy that is going to cover all the elements, not just from scratch, not just I would like to do a prediction, but I would like to do prediction that's going to utilize this data, probably connect to more data that I need separate project for, and go to the reporting phase. Like, just when you're doing it, do it holistically, so that your investment is worth it, and so that your resources and the results that you're getting are really worth it. Machine learning and data science is giving, and AI, of course, they're giving long-term results. Like the short term, of course, you can see the short-term benefits, but the long-term results and the long-term benefits are really the special ones, and the ones that this whole buzz around is about. So now I'm going to kick it off. So kick it off for you, but I'm going to really do the demonstration that I promised to do in the very beginning. So hopefully you still see my screen. I've helped myself a bit. So first of all, I'm opening up the Microsoft Azure Machine Learning space that I've already described for you. So, and at the very beginning, this is the space that you can use for conducting your models. Here, you can be working with notebooks. You can be using AutoML, so automated ML, and you can use the designer in order to manipulate your data. These are some of my recent resources that are not important right now. On your left, you can see that you can start and you can alter these three functions here. But these are the assets that you're working with. So in the first part, you can see the registered data sets. And here you can create the data set. So you can import from local file, you can select from data store, or very beautiful, we can get from open data set. So when we're getting to the part of the open data set, here we can just go through some of the information that is really really ready and prepared with Azure. There are so many online also data sets that are open for you to do some tests. But it's a variety of data, so that you can choose the one that is very similar to yours, or the one that looks like yours, or the one that gets to the model that you want to do. So I can take, for example, New York City safety data, just click next, and then give a name, test life global Azure. Okay, create. Here you can use filtering and so on. So super. As you can see, it's not required for you to be a data scientist or a data analyst in order to do that. It's very simple. It's just a few clicks. And here are all the experiments that you're going to do, pipelines, models, and so on. Now I'm going to get to the designer phase that I told you about. And this is the drag and drop functionality that is actually pretty familiar from before. We used to also work with Azure Machine Learning Studio. But with the designer phase here, you can go into sample models, right? As you can see here, for example, movie rating tweets. You can get out, just go into one of those, one of the sample models. And you can see that this model has already been drawn for you, right? You have the data system here. Okay, let me just... Okay, so we have movie ratings, IMDb movie titles. And then see here with the drag and drop, we're even joining data, executing Python script. So really you can write your script and just paste it here and execute it on the data. And you can see that we are removing duplicates, splitting the data, and really going into the evaluate phase. So this is a model that has already been developed for us, and it makes it easy if you want to just change the data set and use what's already been built. If we go back to the designer, we can just start from scratch very easily, and we can go to the data sets. As you can see, it's already here. So this is the safety data, the New York safety data. And if I right click on it, okay, I can just go into the visualization phase and see what is the data that I'm talking about having to do with my analysis further. So it's loading a bit. Okay, so what you can see here is that this is the different data type, subtype, time, and you can be... This is not a numeric one, but okay, this one is numeric. You can see the mean, median, mean, maximum, and the different visualizations of the variable that we're having right now. This is important because the data set itself and the summary and the summary statistics usually takes us a bit of a time in order to see, do we have missing values? And if we have missing values, what do we do with that? Because if we start with the machine learning modeling afterwards and we have not considered the missing values, then we will be in trouble. And then now here we can go into like different data transformations. You can see adding columns, row. I'm not going to really get into more details, but if we go, for example, to the clean missing data, I'm going to connect those. Okay, and you can see I can just select the column and do it very fast. Low code, no code, so really it's more on the no code side. But here I can just select that it was the latitude, I believe, save, and then I can just run it and remove it and then visualize the data. This is on a very, very high level. We can see also that we have text analytics here, statistical functions of summarizing data, and a lot of machine learning algorithms. So far, so good. This is the designer, and this is something that you can utilize and data scientists can use to actually accelerate their work if they want to, or just do it from scratch. What is really interesting, and for me it was really interesting for people that have no experience, for example, no experience, it's a bit extreme, but that have not that much of an experience with machine learning, they can create an machine learning from scratch just with few clicks without having the statistical knowledge or without really having the compute knowledge of what machine is necessary or what is necessary at all. So here I can take one of my data sets. I can click just next. So this is the data set where I would like to do the machine learning algorithm. I can do, I don't know, create a new experiment, and my experiment name will be, let me go back. I don't know why is it so slow. Okay, so I'm creating a new experiment, and then I'm saying, so which is my target column? So what do I want to predict, or what do I want to actually do? In our case, it will be this one. And I'm saying that I would like to select a computer cluster. I've done one, but I can just easily click create a new compute. And when I click create a new compute, I can just select the machine that I would like to use for this algorithm, like as simple as that. And then I click next, and we're ready. So I click cancel and I click next. So here we're getting into the very interesting part of, okay, I've loaded the data set. I've said what is interesting for me, which was the bike sales data. And I'm getting into the part of what do I want to do? So classification, regression, or time series forecasting, right? And I can select the classification and click finish. Usually it takes around 30-35 minutes. This is time that we don't have right now. So I'm going to show you the test that I've run yesterday for today's session, as you can see, at 6 p.m. So what we have here is really the details of the model. So who created it, what is the compute target, and so on. And I can also go to the data set to show it to you. So bike data. This is it. This is tabular and so on. Consume, explore. The exploration phase is really interesting because you can do preview or profiling of the data, and the profiling of the data is very indicative because it gives different dates, different seasons. I can see that I have 4 seasons. In general, 731 rows and so on. So this is the data set. I've been working with the data set. Now I'm going back to my algorithm experiment. Okay, and I go to the runs that I've done. So here, if you go to the models part, and hopefully this won't be too much for the machine. My Mac is giving very strange noise, which is due to the sharing, I believe. So these are the different models that have been conducted. And the one on top is the one that you can just click deploy, and you can use for your data set. You can go into the explanations, but here are all the models performed, and there are several pages. I think there were around I'll just click cancel because we don't want to do that. There are around 100 models that have been performed on this data, and you can just select the different ones and check the results that they are giving. So this is about the machine learning studio, the Microsoft Azure Machine Learning. We have AutoML, we have Designer, and we don't have time to go to the notebooks. Just a quick comment, when you click deploy here on one of the models, then in your Power BI, when you go to the transformation of the data, you'll see Azure Machine Learning at the very right corner. When you click it and you've deployed this model, it will run on your dataset. It's very easy. There are so many tutorials on that are actually very short. The cognitive services that I promised to also show you in this respect, you can check out on the website. And I'm saying on the website because they are short demonstration, because today in 1 hour I cannot do that. But for example, you can go into text analytics, sentiment analysis, key phrases extraction, and so on. And you can see what could be an output, for example, of that. So understand what is the language, really detect key phrases, and then check what is the sentiment of the text that we have provided. Integrating this API into Power BI can actually really speed it up and make it very accessible for you to use it. Something that I forgot to show you is that in AutoML and the machine learning, you also have data labeling for image recognition, but this is another topic. And the last thing that I want to show you, so this one, please take a look, try it out. It's very interesting. It's like a game for the web search and so on. And then after the cognitive services, I would really like to go into my Azure portal and show how to get the data science virtual machine. So if you right now don't have any resource at your organization or at home, just go to Azure. You have this free trial, and then just type down data science virtual machine, and you can see that you have Ubuntu, we have the Windows part, and if you click it, also cognitive services here and everything's here, but if you click here the virtual machine, you can see that there are the highlights of what you are getting there. Really create it or start with the preset configuration. So depending of what you want to do. I have my own that is hopefully running. There is an auto shutdown that did not start. So I can start it, stop it from here. And once I start my machine, I just can click connect. As you can see, I'm with Mac, and Power BI does not run on Mac. So I'm using my virtual machine if I want to do some kind of visualization. So I'm downloading the file. Okay. Very quickly, I have my username. And as you can see, within several minutes right now, probably my connection is a bit slow, but right now what we can see is that it will connect to the virtual machine, and we can directly start working with that. Okay, I will cancel it so that we don't have problems with the network. With this, I would like to stop my presentation. Really wish you a lot of luck with your strategy. It's AI and data. It's beautiful what you can do with them, and it's beautiful really what you can design as solutions, as visualizations, and the fire in the eyes of the business people and the IT people that can actually utilize their data into making the right decision and into really getting a step ahead. So thank you very much. This was from my side.
Thank you so much, Ekaterina. That was awesome. Heaps of detail, and the demonstrations were really fantastic. So thank you ever so much for your time. We really appreciate that. And thank you for everyone who's engaged in the comments. Good to see some stuff there. We've dropped a few links in there where you can follow the reactor and pick up on other things. Just a reminder, this is part of a entire kind of global activity. So if you want to head to globalazuredays.net, I think it is, then you will find lots of other kind of similar sessions. But with that, I think we will leave it there. Thank you so much again. And hopefully we'll see you again soon. Thanks, everyone.
Have a lovely day. Bye.
Cheers, you too.